We have a series of webinars, so this one will be on supply review. So for people who attended the previous webinars, they already know that as Solventure, we really try to be active in the full SiOP cycle, starting with a more tactical, strategic segmentation of customers and products, which basically should steer all of the steps in the SiOP process. Product management review, which links into the product managers and R&D, and is managing the product lifecycle aspect, and specifically the introduction phase, where we see that a lot of the business cases are overstated, but at the same time, some forecasts may be underestimated. So being short on the ball there is essential in making the NPI process work better. And the end of life, where we see that a lot of companies keep too many products for too long. So how do we avoid getting with too much obsolete or non-moving inventories? That's two key questions of the product management review. Forecasting, demand review, I think is well known. We had a webinar on inventory optimization. This one will really talk in detail on supply review, so the supply planning, where basically the forecast or the demand is an input and where the optimal inventory parameters are an input. And supply planning is really the step before we can go to the executive SiOP, where we want to hold a webinar on in December. At Solventure, we really combine process knowledge, so we're not just tooling consultants. We try to bring advice on how to organize your supply chain processes. We use the Arkieva tooling. In fact, we are distributing it into Europe, and we use the tooling to improve processes. We try to have good knowledge on analytics. If you think about demand planning, it could be statistical forecasting. When we will be talking about supply planning, it's clearly something like linear programming, optimization techniques, which you can help which can help you to optimize your plans. And make sure you also don't forget the people aspect. I will also come back to that today in the context of the supply review, because not every company may be ready for a more advanced solution like the LP optimization. So that as a short introduction of Solventure. This slide basically shows the same, but it provides some more details. So if you look at supply, last month we had a webinar on rough cut capacity planning. Today we will talk about master planning and detailed scheduling. These are some of our customers. So we have customers in different types of industries. We try to be very expertise driven. So it's basically at S&OP process expertise, which makes us active in projects in those different industries. And we recently launched 2 new business units within Solventure. So one is Solventure Academy, which is a training institute, which helps you with developing your supply chain knowledge in 2 ways. So we will organize what we call accelerator days. So these are open trainings where people from your company can participate. We will organize them in Belgium, the Netherlands, and Switzerland in 2017. And we can also do boost camps in your company internally. So if you say I have a team of 10 to 15 people that needs to be trained in the overall S&OP process or specific aspects of the S&OP process, we can help you from the Solventure Academy perspective. We also launched Solventure Live. Live is leading indicator forecasting. So that's, you could say, the next level of forecasting. Instead of just extrapolating recent history, what we do is we look for external macroeconomic indicators which have, let's say, a leading effect. So if you're delivering into automotive or you're delivering into construction, which type of indicators can help me to predict 2 to 3 months early where my business is going to go. And this is based on master theses and PhD research. We have quite spectacular results. If they would be interested, feel free to reach out to us, and we will be more than happy to show you where we currently are with that solution. But let's get started with the supply planning topic we had scheduled for today. So I want to kind of recap what we already discussed in the previous webinar on RCCP. We believe that there is 3 dimensions in supply planning which you need to take into account when you look at your supply planning processes. And then I want to spend some more detail on, okay, what is then the difference between detailed scheduling and the other levels of supply planning before Edward is going to show you how Arkieva can support detailed scheduling. These are the 3 dimensions. So there's a vertical dimension, which we'll shortly review. I believe there's a horizontal dimension, so really the supply chain dimension, and then a 3rd dimension, which is also quite important, and which combines maturity and complexity of your teams and of your supply chain. Hierarchical. Well, we believe that if you want to organize your planning in a good way, you really need plans on different levels of detail. I think many companies do have a strategic plan with some of the characteristics described here. So 3 to 10 years out, quarterly or even yearly buckets, typically driven by the CEO or BU president, could potentially be supported by a strategy office. And what it really tries to do is to set the commercial direction of the business, like, okay, which type of markets do we want to be active? What are the innovation plans? What are any major capital investments to be successful in those markets? Acquisitions, divestments, partnerships, and so on. Major input, let's say, towards the more supply chain type of planning is that here we typically define the supply chain network. We already define in which markets we will be active, which selling markets, which demand markets, and that will be an important input, let's say, to our supply chain planning. Most companies make budget. September, October is an extremely busy period. That's what we see, at least with our customers. We try to make a plan for next year, next fiscal year, monthly buckets. Some companies may do a half-year review or a quarterly review. Some companies simply do not do a review. It's driven by finance. It's kind of an intermediate level of aggregation. It takes the long-term plans as an input, so it takes the strategic plan as an input. At the same time, it tries to make realistic estimates of what's now the outlook or the expectation for the next fiscal year. It has to do with planning, but it also has to do with target setting, like what are the targets for the volumes, for the pricing, cost, margins. It's an allocation of financial resources, and no budget means no project. So in the budgeting process, we define where to invest and where not to invest. It leads to a P&L, balance sheet, and cash flow for the next fiscal year. And basically, it tries to define a financially viable plan. And in many companies, instead of viable, it is also a little bit stretched, and that puts a strain also on the rest of the S&OP process. That's budget planning. Aggregate or rough cut capacity planning, that's basically what we discussed in the last webinar. So if you want to know more on this one, feel free to refer to our last webinar. 12 to 18 months out, that's a typical horizon, typically in monthly buckets. It's driven by the supply chain department, intermediate level of aggregation. So we're not interested in the details yet. We really try to get the volumes right on an aggregated level. Driven by the S&OP forecast, which ideally is aligned with the financial forecast and the budget, but that's not the case in all companies. So that's also a challenge which we try to support. And the main goal here is we try to identify a bottleneck. So do we have a structural capacity shortage? Do we have a seasonal peak? Will we have a shutdown? Do we have tenders which are disrupting the supply chain? And we try to identify the appropriate solution. And there's only a couple of basic options. You can try to increase the capacity by increasing the number of shifts. You can try to rebalance your demand across different plants, across different machines. You can build inventory, so pre-built inventory to anticipate a certain event. And you can try to outsource or organize a swap deal depending on which type of industry you are in and the possibilities you have there. So this is about defining a realistic plan. We try to come up with a realistic plan, cost efficient, and it's a tactical plan, meaning it's typically on an aggregated level, and it's 12 to 18 months out at a horizon. An important concept to share, certainly if we want to spend some more time on discussing master planning and detailed scheduling, is the so-called free, flexible, frozen period. The free, flexible, frozen periods are defined by your supply chain lead times. So if you look at what is the time that I spend really on producing and distributing stuff. If that would, for instance, be 2 weeks, well, for those 2 weeks, you really need to make a detailed schedule. You need to steer the day-to-day operations. So if your internal lead time is 2 weeks, you typically need a detailed schedule for at least 2 weeks. The master plan will extend that, let's say, to include the purchasing or procurement of key raw materials. So if you say, well, I need 6 weeks to, let's say, buy my key raw materials, then the master plan will typically extend up to 8 weeks. So 2 weeks for your internal lead time and then 6 weeks for buying the key raw materials. So your master plan would then extend up to 8 weeks. As we extend up to 8 weeks, instead of doing it in daily buckets, it's quite typical to do it in weekly buckets. The RCCP would then typically go beyond your supply chain lead time, beyond the 8 weeks. And if we're looking 12 to 18 months out, we typically do it in monthly buckets. The RCCP typically has little constraints in the sense that I still have to order my raw materials at my supplier. So that's why we say there is little to no commitment yet. We call it the free period. And as it's shown here at the bottom, here we typically try to manage the supply to meet the demand. So we try to stretch the supply so that we can meet the demand changes. The closer I get to the production, well, the more decisions I already made. I already ordered certain raw materials. It may be difficult to get some extra. I already started a specific production, maybe of intermediates, which already commits extra costs and reduces the options I have. So the closer I get to the final production date, the more committed I am, and so the more frozen my schedule becomes. So these are some typical planning lead time concepts. So as discussed, master planning, depending on the supply chain lead time, could be 8 to 12 weeks out, typically in weekly buckets, weekly updated. It's driven by production. So if you have multiple production sites, you might have a master planner in each of the production sites, or you might have a master planner for a group of production sites. But it's typically closer to the production. It's on a detailed level, so where the RCCP is typically on product family or an aggregate level, the master planning is really planning SKUs. Here it's about the detail, it's about the mix. It's driven by the rules, the allocation rules, the capacity and the inventory is decided in the RCCP. So in the RCCP, we may have decided to reallocate demand from plant A to plant B. If we decided that on the RCCP level, it will be an input to the master planning level. In the RCCP, we decided on certain capacity levels. So we decided to increase or decrease capacity to meet certain demand. If that has been decided in the RCCP, it will be an input to the master planning process. Same for inventories. If we decided to build up or build off inventories in the RCCP, the inventory targets will be an input to the master plan. If you look at the master planning, it's typically done, if you look at the RCCP, it's typically only done on forecast. If you look at the master planning horizon, 8 to 12 weeks out, well, I might, next to forecast, also have orders. So depending on the customer lead time, I might have customer orders for next week or the coming 2 weeks or the coming 4 weeks. So in the master plan, next to the forecast, I will also account for the specific orders I already have in the portfolio. It's about planning the mix, where RCCP is about planning the volume. Because we are planning SKUs, we account for what we call mix variances. So if there is differences in run rates, if I need to group SKUs in specific campaigns to make sure that I minimize changeover times, this is complexity which is taken into account in the master planning process, which is typically not taken into account in the rough cut capacity planning process. In the master planning process, I also start prioritizing different demand streams. So I may have customer orders, I may have forecast, I may have the replenishment of safety stocks. Different demand streams may have a different priority, and I might use those priorities to make decisions in a constrained capacity situation. So we get into more detail. We have the capacity plan inventories as an input for the RCCP, but typically we also refine them. If you look at capacity, well, the capacity might be defined, but it's still a rough cut plan, right? So it's a rough cut capacity plan. In the master planning, I might still fine tune what's the number of temporary workers I want to have next week. So that's typically a bit shorter term, shorter horizon, and it's a fine tuning of the capacity plan. If I look at the inventory buildup in the RCCP, I may have decided to build up inventory, but I've decided that on an aggregated level. In the master plan, I still need to decide which SKU I will actually build the inventory. Will I do it in a fast mover? Will I do it in a slow mover? And what's the pro and the con of the two options? This is all master planning stuff. And the result of the master plan is production orders, planned production orders, which you can load into your existing MRP system if you would have one, or which you can load into the Arkieva MRP, and then the Arkieva MRP can trigger the Arkieva detailed scheduling, as I will discuss later. So if we look at the summary of the master planning, it's about a realistic, cost-efficient and viable operational plan. Key difference with the rough cut plan is that the master planning is really about the details. It's about specific SKUs, it's about the mix, whereas the rough cut plan is really on an aggregated level and is also from that perspective a bit further out into the future, into monthly buckets, where the master planning really looks at your supply chain horizon and typically does that in weekly buckets. Another important concept in planning is the customer order decoupling point. So this one says if we're made to order, well, we will replenish raw materials and components based on the forecast, but the rest of the operations will be done on order. Well, the master plan is typically steering what we call the customer order decoupling point. So depending on the situation you are in, your master plan may be on a different point in your supply chain, the customer order decoupling point. So next topic is detailed scheduling. I will not discuss it in detail here because I will come back to it. But okay, once you have your planned production orders, you run it through the MRP, and then the MRP will typically take the result and map, let's say, the jobs on your specific assets. We will come back to that. That's a summary. We will send the slides afterwards, so that might be good for you to review. So the first dimension was the vertical dimension. Second dimension is the horizontal dimension. So I also have a supply chain which I need to plan. I start with customers which I may deliver from distribution centers. In production I may have downstream production, upstream production. I may need to involve key suppliers because they define the adaptability or the flexibility I have in the overall supply chain. So I also need to look at that horizontal or that supply chain aspect. I typically start from a forecast and orders, let's say, on the customer side. I can use DRP to net the stocks in my distribution centers and calculate the dependent requirements to my product towards my production. I typically use MRP calculations to start from a finished product plan and translate that into semi-finished or raw material requirements. And so the typical direction is from right to left. It's from the customer up to the supplier. Sometimes I also have the need to say, okay, if I have an issue with a key supplier that product will be coming in late, I want to know which production orders of semi-finished, let's say, are in trouble. And if these semi-finished orders are in trouble, how will that impact, let's say, the production of finished product? So if we want to go from left to right, so from the supplier back downstream to the customer, what we need to do is pegging. This is basic planning functionality. It is available in Arkieva, but it's also important that you map out, like, how does my supply chain network look like, and which type of requirements do I have to, let's say, make a good plan. This slide combines the vertical and the horizontal dimension. So the vertical dimension really goes from the strategic plan down to the schedule. The horizontal dimension says, well, okay, I go from distribution all the way up to my suppliers. Strategic planning and budgeting certainly take a look at the holistic supply chain. So here we really look at the end-to-end supply chain. If you look at the rough cut plan, I think in general rough cut planning is also done for the holistic supply chain. We will look at where the key bottlenecks are. We will try to plan those bottlenecks and will derive, let us say, the upstream and the downstream plan from that bottleneck plan. On the rough cut level, we typically also use simplified bill of distributions, simplified bill of materials, because remember that we are on an aggregate level, so we might at that level not be concerned about specific runtime differences between specific FQUs. Yeah, we might use aggregated BOMs or simplified BOMs. If you go to the master planning level, there you typically do have plans for the different steps in the supply chain. Certainly also if you go to the scheduling, you do have plans for the different steps in the supply chain. And in this slide, we also try to map out how these different levels integrate. So a budget will define the available resources, right? The available resources will be input to the rough cut capacity plan. Within those resources, for instance, the plants I have available, the capacities I have available, I will try to optimize the plan. I may define certain allocation rules. I may define certain, let's say, build up or build off of shifts to increase or decrease my capacity. I may define on the buildup of inventories. This will be an input to the master planning. The master planning will be, let's say, deliver planned production orders towards the scheduler. And you also see that there is a feedback loop. So mapping out your planning landscape is probably key. And we see that many customers would like to skip one, but we will come back to that. If you try to skip one level, you might just risk that you over complexify the remaining level. So be careful when you do that. Third dimension was maturity and complexity. What we basically say is that if you have a low complexity, you can do with a basic solution. Yeah? If you have a high complexity, you need a more advanced solution. Yeah? But be careful, also take into account your maturity. Because even if your complexity is high, yeah, well, it makes sense to start with a basic solution if your current maturity is low. Yeah? So make sure that you start with a basic solution before you step towards a more advanced solution. And how do you define complexity? How do you define maturity? Well, we've listed a couple of checks here. So we sometimes see people saying, well, in my operation, the bottlenecks are shifting. Sometimes it's downstream, sometimes it's upstream operation. I have multiple BOMs or recipes for the same finished products. I have complex changeovers, specific production wheels. I'm very asset intensive, so some assets always need to be loaded to be cost competitive. The more of these, the more complex your environment will be. How do we assess maturity? Well, it has to do with the experience in your planning team, but it has also to do with, what's the quality of your master data? What's the quality of your cost data? How much experience do you have in the use of advanced tools? What are any recent improvement projects that you did, right? And trying to jump to a very advanced solution, if your maturity is very low, that has a big risk, because more complex tools can turn out results which are less intuitive, and you really need good data and experienced people to be able to, let's say, to get benefit or draw benefit from that type of solutions. And based on that experience, this is a kind of a roadmap that we typically propose to the companies we work with. Like, if your maturity is low or your complexity is low, basically you can do with what we call a planner-driven approach. And it means that the planner is in the lead. If the question is to, should I build up inventory? Should I offload demand from machine A to machine B? Well, we typically, in this type of situations, want to put the planner in the lead. On the one hand, it's manual, but at the same time, it's understood, right? And before you go to next levels of complexity, make sure that you have the right maturity for that. Next level could be rule-based. So if your planners are being experienced or are building experience in the planner-driven approach, well, if there are some default rules which you always apply, like I first always balance this machine and then I balance that machine, and these are typical ways to do that, then we try to capture that in rules in our rule-based engine, and that takes away some of the, let's say, repetitive work from planners. And we advise this type of approach before, for instance, you step to an optimization approach. In an optimization approach, well, the planner is no longer working, let us say, on the output of the plan. Instead of managing the plan, the planner will start managing the inputs. So he will start managing, like, what are the BOMs, what are the routings, what are the capacities, what are the costs, and by managing those inputs, he will steer the optimizer, let's say, towards certain results. But in the optimization approach, it's the optimizer or the optimization engine which is in the lead for defining the optimal plan. If your complexity is bigger, there is extra benefit for switching to an optimization approach. Another thing we see is that if you go to an optimization approach, well, optimization engines can deal with more complexity. So it's typical for an optimization engine to at the same time look at the mix complexity, so specific SKUs, and also look at capacity planning, and for instance also do that in financial terms, which can support your budgeting process. So in an optimization approach, you can deal with more complexity, whereas in, let's say, that planner-driven approach, you typically try to split that complexity into different levels. And Arkieva is working on even a next level, which you could call dynamic optimization, where basically also the scheduling is integrated into the master planning, into the rough cut planning. So you will basically have one plan, and depending on the level of detail you need, you will look at the detailed schedule for the next 3 days, or you may aggregate everything into monthly periods and look at the next 12 to 18 months, let's say, to support your S&OP plan and a rough cut plan. So this is a roadmap we see. So depending on the maturity you have, depending on the complexity, you may choose a certain roadmap throughout these, let's say, this journey. So that was the first step. So again, summarizing a bit, what are the 3 dimensions in supply chain planning? The vertical dimension, so really try to think of which different hierarchical levels of planning do I need. Think about the supply chain dimension, so what are the steps which I need to plan and how do they interact with each other? Do I have a good bill of distribution, bill of material engine to explode demand and to do pegging? And then think about the maturity and the complexity dimension. So what is my complexity? So what type of solution do I need in the long term? What's my current maturity, and what's a realistic roadmap towards, let us say, the optimal or the best possible solution for my level of complexity? And before I pass the word to Edward on detailed scheduling, I want to briefly say some things on the detailed scheduling. So I already told that we start from the master production schedule or the master plan, which will generate planned production orders. The MRP may generate shop orders on different steps in the supply chain, and these shop orders will be scheduled by your scheduling engine. And so basically, as it's shown here, a shop order needs to be translated in jobs. Jobs have certain due dates on certain machines in a certain work centers. They need to be put in a certain order or a certain sequence. So you see scheduling and rescheduling. Why? Jobs may be delayed, they may be preempted, you may have unexpected events. So it's scheduling and rescheduling. And yeah, the type of scheduling you need depends on your environment, and it also depends on the type of objectives you have. And we will show some more of that in the next slides. If you have a schedule, it's dispatched to your shop floor. It can be dispatched on paper. It can also be dispatched to a shop floor management system. So basically your scheduling solution will control what is happening on your shop floor. So scheduling is about jobs which need to be put on machines. It can be a single operation, it can be a collection of operations, it can be a single machine, or it can be a collection of machines. So a job will have certain characteristics. This is an example of a couple of jobs which have a certain precedence relationship. They have processing times. I will release jobs to the systems. They are due at a certain time. I will start them at a certain time. I will complete them at a certain time. They can have certain weights or priorities. And the machines can have a certain route or a certain sequence. If the routes of all the jobs are identical, we typically talk about a flow shop. So that could be the case in a kind of continuous process type of environment. It could also be the case in a, let's say, quite standard assembly type of environment. You can have job shops where you say I have different machines and different jobs have different routes. And so 2 routes are shown over here. I can also have job shops with recirculation. So for instance, in semiconductor, it could be that jobs need to pass through the same machine a couple of times to reach a certain level of quality. In general, the more you go to the right, the more complex your scheduling problem will be. So we have jobs which need to be scheduled on machines. We will have certain constraints. Without trying to be extensive, these are all possible constraints. Precedence. Not every job can be run on every machine. I may have a constraint on workforce, on routing, on material handling. If 2 machines are connected by, let's say, an automated material handling, I may need to synchronize stopping times and starting times, sequence-dependent setups and times and costs. I also have certain objectives, so I can try to maximize the throughput, which is basically the output. I can try to minimize the make span. So the make span is the time when the last job leaves the system. So it's kind of the cycle time in the system. I can try to minimize some due date related objectives. So I can say, well, I try to minimize the maximum lateness or the average lateness or the number of tardy jobs or the number of jobs that will be too late. I can also account for the weight or the importance of the jobs. So I may say, well, if I'm too late, it's more severe to be too late for a customer order compared to a replenishment order. So some of these objectives I can take into account priorities. I can try to minimize setup costs, work in process or finished goods inventory. So this slide tries to summarize what scheduling is really about. So we take the results of the MRP, we translate that into scheduling jobs on specific machines within certain constraints, trying to maximize certain objectives. And depending on the complexity we have, well, for some of the most simple problems, we have known and optimal solutions. So if you have a single machine, there is known techniques like the earliest due date first or the shortest processing time first. So these are known scheduling approaches which allow you to reach a certain objective. For instance, minimize lateness or minimize waiting times. If you go to more complex problems, so if you have that circular job shop and you try to optimize multiple constraints at the same time, there may be no known solution. There may also not be a known optimal solution. So you might resort to what we call a heuristic. What is heuristic? Well, we deliver a good approximation or a good solution within a reasonable amount of time. And for some specific cases, optimal methods are known and have also been made available in the Arkieva scheduler. Feel free to post some questions, so people who still have 5 minutes, we're happy to take 1 or 2 questions. So if you go to your screen here as it's shown, normally there is a question box which you can click open. So here you can enter any question you could potentially have, so feel free to post some questions. We'll try to take 1 or 2, then close down the webinar, and if there are some questions which we've not been able to answer, we'll be most happy to come back to you at a later stage. Also, as Edward mentioned, probably the functionality of the schedule is too rich to give it in this type of short time span or time period. But also there we're most happy to give more details at a later stage. So not sure if anybody has a question. Just take a couple of seconds. Okay, we have a question here. Is there a link to an ERP system for the scheduling tool? I'll pass that to Edward. So how do we interface with ERP systems?
Yes, I mean, Arkieva comes with a standard certified SAP interface, but even if you have a different ERP system, there's various ways of getting the data from the ERP, from a simple solution such as flat files to essentially a data mart where you put in your master data, your customer orders. You could even feed in from your forecasting solution, upload schedules from your existing schedules from your shop floor system. So those are standard interfaces that we're used to working with.
So there's another question here. Do you often see clients sharing the same detailed schedule screen across, say, a plant and a central planner? Say 2 weeks for the plant and then the next week for the central. So I think the question there is, do we have planners at different levels, central or at the plant, looking at the same schedule at a different level of detail? I'll again pass the question to Edward.
Yes, so first of all, we can differentiate the schedule into two ways of operation. We can say, look, when this person opens the schedule, it's always in read-only mode, so he can do whatever he wants. The other thing is that you agree on, if you're working on the same resource, short-term and long-term, then you have to have a process whereby you don't step on each other's toes, obviously. But we do have live examples where, for example, you have a complex plant with shared resources, but you have different planners, where each planner has their own scenario, and we then have one master scenario which consolidates the two. So they can work independently and push their data and pull their data to and from the official scenario, if you will, and that way there's no what do you call that? No interference between the two.
Okay, I think we'll close down here. We're already 5 minutes past the timing we had foreseen. So thank you all for attending this webinar. We'll be back with a webinar in December. So that webinar will be on the executive SiOP and how to organize that. Feel free to keep on posting questions. The questions we've not been able to answer now, we will answer them at a later stage. We also remember you to visit the recordings of the previous webinars. We'll also have a comparable webinar schedule next year, so more of that coming to you soon. So thank you for participating, and we hope to see you back in one of our upcoming webinars. Thank you.